Hello.
Is it going to be more
Hello.
What's up?
Thank you all for coming. Appreciate it very much. I'm Farron Griffin. I'm chair of Bethel's Conservation Commission, and tonight we welcome you for a climate forestry talk. We're waiting for the presenter. She just flew in today. She should be due here any minute. And before I hand you over to a fellow CC member who spearheaded this presentation, Danny Dover, before I hand it over to him to talk a little bit more in depth about it, I am compiling names to be on the Conservation Commission email list. We have a few projects going that we're doing. One, we're doing a timber harvest in Quimby Town Forest here in Bethel. And throughout the process, we're going to involve the public to come at a few of the steps, a few of the phases. So if any of you are interested in being a part of that and seeing how that happens, we'd love to have you. I can take your name and email here for that. And other than that, hello.
I'm here.
Danny, would you like to say something real quick, please, for us? Yeah.
There. Let's see, first of all, make sure you got it.
There. Apologies, I thought this was at 6:30, so
F-E-R-R.
I'm early.
Go ahead. Aaron, we can get more chairs.
Do we need more chairs?
Do we need them?
Here.
There's one more here.
Okay,
He's
I'll
in.
take that one.
Yeah, and Jean's
Yes.
hanging out up there.
Okay.
Brand new. Brand new. Page 2.
Okay, perfect.
We have
microphone to wear?
Sure.
8 or 9 people.
I also might be able to project loud enough.
I think so. Not for us.
Oh,
Yeah.
recording, okay, okay. Okay, thank you for bearing with me, everyone.
We introduce ourselves on the
Al, do you mind me telling everybody that this is Al Freeman from Kansas City? No.
Today.
Today is, she's from Kansas City. She didn't mean to be coming from Kansas City, but she had a flight last night that was rescheduled for this morning.
Thank you.
And so,
Thank you so much.
And if everybody
Glad you made
doesn't
it.
know
Yes.
all the Conservation Commission members, I'd love it if all the members here could just raise their hand at least and introduce yourselves.
Should we start? Shall I
Yes,
start?
You should
please,
I would
please.
really like it if everyone would introduce themselves, because I don't know everybody.
We'll follow with that. First we'll do members.
Okay, I'm Mary Floyd, I'm co-chair.
Emily Miller, I'm secretary, I guess.
Danny Dover, member, Conservation Commission. Bethel.
Stephanie Nizio, newish member.
Mark Heckman, Bethel, member.
Lisa Campbell, Bethel.
And please introduce yourselves to us and let us get to know you.
Sue Webb, Bethel.
Eric Webb, Bethel, Planning Commission.
Diane Tietzel, person for Rochester.
Betsy Geiser, Tunbridge Conservation Commission.
Oh, nice.
Derek Underwood.
Ellie Griffin, Recreation.
Mary Pavoni, Bethel.
Kate Reeves, Barnard Conservation Commission.
Sir?
Steve Webster from Randolph, I'm a Bethel landowner.
Chris Pellerin from Barnard.
Winslow, we're in Bethel.
Beth here, Bethel.
Yeah, I'm gonna scoot this way just so people.
Nancy Paisley, Bethel.
Is that all up front?
Brett, sorry. Simultaneous.
That way I'm out of the way.
Great, thank
From
you.
Bethel. Yes.
Thank you all for
So you're about 30 to 40 minutes, is that what you said?
Yes, it should be about 35 to 40.
Okay, then we'll have time for, yeah.
Yeah, perfect.
Okay, well, welcome for coming, everybody for coming, and so glad to be here. This is Al Freeman, Vermont State Climate Forester, and you've seen where the bathroom is, just over here if you need it. And Orca Media is here. We're glad to have them being able to film this. So eventually that'll be up, available for anybody who wants to review this or you want to pass it on. You can just do a search for Bethel State Climate Forester. It should come up in, sometime in the next week or two on YouTube. Here, there's a seat here. You want? Oh, hey, Dave. Didn't recognize you in your costume. It was good. Okay. Well, thank you very much. And so Al says this presentation will be about 30 to 40 minutes. There'll be plenty of time for some questions after. So.
All right, well, thank you all for being here, and sorry I was late. I've been up since 4 a.m., so if I start falling asleep, just throw something at me. And as he mentioned, I am the climate forester for the state. I'm also a PhD candidate at the University of Vermont, where I research climate adaptation, forest management, and how that impacts tree physiology. And so for today's talk, I'm going to be kind of blending my research at UVM along with my kind of applied forestry background with the state. So we are going to be talking about Vermont's forests and climate adaptation, and so looking to the past, the present, and the future, and how we make our management decisions. And I always like to start out my talk with an outline. That way you kind of know what to expect, and you also know when it's wrapping up, because I know it's dinner time, and we won't go on too long. But we're going to talk about past land use history, which will put us in the context of how our forests are today. This will allow us to understand forest resilience and adaptation and how we can plan for that. We'll then get into climate change in Vermont, how it's presenting itself, talk about the stressors our forests are facing. And so with that understanding of those pressures and how we can add in resilience, we'll start to talk about how you can assess vulnerability in your own landscape and start planning for those future stressors. So diving into past land use history, I think it's really important to note that people have always been part of the landscape here in Vermont. And to depict kind of forest succession through the history of colonial settlement, I'm going to be showing these pictures from the Harvard Forest Fisher Museum. If you've never been, it is spectacular. These are these hand-built dioramas that kind of go through past land use history, forest management. It's really spectacular if you are a big forestry nerd. So it's the Fisher Museum, just plugging that one more time. It's where all these photos are going to be from. Where is it?
Oh, I'm trying to remember. I think it's Petersham or Petersburg, Massachusetts. I can't remember the exact town, but highly recommend. So this first picture is depicting early settlers in 1733. So you can kind of see from this photo, we still have a lot of old growth forests. There's about, I believe, 80% of the landscape is still forested at this time. But we're starting to see more agricultural clearing. You'll notice, it's pretty level. Stones are being lifted and loosed. They're building those stone fences. Tree stumps are being removed. And so with an old growth forest, we oftentimes have, I can move this for you. What we see are called pillows and cradles in the landscape. So there's lots of little microclimates. And so when we have this type of clearing, it is really changing that soil composition and that kind of ground structure. There were also a lot of cultural fires occurring here and, different habitat manipulation. But in general, we really still have those really old growth forests. So if we fast forward about 100 years from there, we reach the height of the agriculture boom. We have the sheep craze, the timber boom. About 70% of the land was cleared at this point in time. So there is not a lot of forest left. We have a lot of agricultural settlements and a lot of young forest during this period. About 20 years following that, we have a lot of farm abandonment. So this is a product of the Civil War. We have a population decline and people are starting to move west. And so in these areas, as we kind of talked about, when we have a lot of agriculture, when we have a lot of massive, timber cuts and we're completely changing the landscape, we're changing that soil composition. We're changing kind of that natural structure we have. And so the species that are going to move in here are going to be really well established in disturbed sites. So that's going to be species like white pine. So a lot of these early forests are going to predominantly be those large old white pines that we see in those old farm fields. About 60 years following this kind of places us in 1910. Those old white pines are now at that age where a lot of them are getting cut. So these are pretty widely getting clear cut in the area. It's being used for further expansion, you know, building railroads, all of that. And white pine was really great. It would be, you know, because it's a softwood, it floats down rivers, so it's very easy to transport large distances. So a lot of this pine is cut. And what follows, about 5 years following that initial harvest, is going to be hardwood succession. So this is starting to lead into the forest that we see today. And so a lot of these hardwoods are coming in from other areas. They also have a long shelf life, if you will. They're probably in that soil, and so the conditions are finally right for them to start emerging. And so again, this is about 1915. We're gonna have some white pine slash still in the ground, but we don't have a lot of dead wood. There's a lot of things kind of missing from these forests that were historically there in old growth forests. So about 20 years from this establishment, a lot of that white pine slash that was left on the ground is now gone. We don't have a lot of dead wood on the ground. And we're seeing a lot of pin cherry. We have a lot of aspen. These are really fast growing species. They're early successional species. So those are going to be kind of crowding out our sugar maples, our red oaks. And although it seems like, oh, maybe they, you know, need some tending to, if you let those species grow, they take about 50 to 70 years. Those are going to fall out of the overstory and then allow those more slow growing species to then take in. And the beautiful thing with those early successional species and why they're so important is those leaves have a lot of nutrients in them. There's a lot high nitrogen content, and this can further enrich the soil and start to kind of build up some of those pieces that are missing that species like sugar maple really need. So 1930, we're starting to see, you know, those more slow growing species to come in. And so now, today, more than 80% of the region is forested, which is really amazing to think about because, you know, not that long ago, 70% of it was deforested. And majority of these forests are going to be between 40 and 120 years old. And so these are still relatively young in the context of a forest, but it seems very old for us. And the important piece here is we are starting to a lot of these are starting to get to that mature age, but they are missing some of those key characteristics like deadwood, and we'll get more into that. And many of these forests that we see today are oftentimes going to have a simple structure. And so what I want to get into now that we kind of have placed the context of where our forests are at today, I want to talk about how we can view them and think about resilience. And so I love this trick. These are supposed to be fingers. This is from Audubon, Vermont, and it's this hand lens trick that you can use to walk through the wood. It allows you to kind of have a critical lens, but also it's easy enough to just kind of pick up on some things. And so on one hand, we want to look at the canopy, our overstory trees. Do we have a lot of those? If you're not good at identifying species, that's totally fine. If there are still leaves, which maybe now is not the time, you can differentiate whether or not there's different leaves or different architecture, and that can clue you into if you have multiple species or do you have one dominant species. You can look at the mid-story. Is there anything in that mid-story layer? That's a really important piece because if you have a blowdown or some kind of other event, that's going to be your future tree that's going to occupy that space. You also want to look at the understory. Is there any regeneration? Are there invasives there? Your understory is your future forest and can also clue you into, if you're not seeing anything, you might have a deer problem, and that could have implications on your forest if there's a future event, and we'll get more into that. On the other hand, we want to look at snags and cavities. Do we have dead standing trees? These are really important for wildlife and are also really important characteristics of old growth forests. We want to look at, is there deadwood on the ground? Again, really important for wildlife. We'll get into more of those details. And then we want to look at leaf litter. What is that leaf litter composition? This can clue you into if there's not a lot, you might have an earthworm invasion, and that can have its own issues. If you have a really dominant beech canopy, oftentimes that leaf litter is going to be really, really thick, and that can inhibit other species. And so if you're dealing with beech and you're trying to regenerate something else, that might clue you into, you might need to scarify your soil. And we'll again get more into those details. But knowing what that duff layer looks like can help you decide how you want to move forward with that future forest in your understory. So I hope I run into somebody walking in the woods holding up 3 fingers, or 6 fingers, I guess. But I love using this just to, again, do a quick and fast assessment of your forest. So now I want to get into the nitty-gritty of forest resilience and adaptation. So how do we understand whether a forest is simple or complex? How do we use that hand lens to assess our forest? So to visualize this, I really love this figure. It kind of shows a simple forest structure versus a complex forest structure. So in a simple forest, we have kind of all the same age, all the same species, maybe 1 or 2 different species, versus a forest that has multiple age classes. It has the overstory, midstory, and understory. You might have some conifers and some hardwoods. And then if we think about that circle there as an event, let's say it is an ice storm, or you have emerald ash borer invasion. If you have a simple forest structure, you have less recovery pathways to respond to that event. If it's a drought, you have 1 age class, 1 species, likely they're going to respond very similar. Where if you have a more complex forest, they're going to respond in a much more flexible way. And so to put a definition to it, resilience is the ability to withstand and recover from a disturbance, such as a climate event, pests, and pathogens. So now I kind of want to get more into those details of what makes this kind of complex forest here on the right more resilient than the forest on the left. So the first one I want to get into is we want a diversity of tree species in our forest. This is really important because, again, not all species are going to be susceptible to the same challenges. Some are more drought resistant. Some are going to have wet feet and can handle our extreme precipitation events. And so again, having that diversity of responses can help that forest have more recovery pathways. It's also important because they fill different needs for wildlife. We have what are called soft mast and hard mast species, and masting is just a word for fruits and nuts that seeds produce. And so if you have a diversity of species, you're going to have different food availability for wildlife. We also have a lot of, we're finding, I'm forgetting the researcher's name, but I believe they're at SUNY ESF, but there's been a lot of recent pollinator studies that are showing that early season pollinators really depend on species like red maple that are some of the first to flower because there's not a lot of other things out on the ground. And so these, are really great for our wildlife, big and small. And the other part I like to highlight is different species are going to leaf out at different times. So ash is really critical for spring ephemerals because they're the last to leaf out. And so you get those pockets of sunshine on that forest floor. And that is really important for those spring ephemerals to kind of have a little bit of that protection, but a little bit of sun. And so ash, for many reasons, is important on the landscape, but that's one of my favorite facts about ash. In addition to diversity, we also want redundancy. And what I mean by this is that if a species is lost on the landscape, we want another species that can fill a similar functional role. And so if you think about a great example of this is beech. So I don't know if all of you are familiar with American beech. We've had beech bark disease for a very long time. It weakens the tree, but we're still seeing a lot of beech nuts that are still viable. But knocking on our door in the southern part of the state is beech leaf disease. And this is caused by an invasive nematode. It essentially affects the leaves before they bud out, and then it allows them to, it keeps them from photosynthesizing essentially, so they'll keep flushing their leaves and can lead to mortality within a decade or 2 of mature trees. And so it's new, we don't know a lot about it, and it's pretty concerning in terms of whether or not beech is gonna stay on our landscape long term. So with the possible loss of beech or a pretty severe decline of beech, it still might always be here. It's important in areas to think about having red oak, having hickories, having those kind of hard masked species that are really important for wildlife like bear, because bear really depend on beech nuts to kind of add that fat layer that they need in the winter. So again, we want redundant characteristics as well as diverse characteristics. We also want various sizes and ages of trees. This is important because some stressors are going to have disproportionate effects on trees of a particular size or age class. You know, windstorms are going to impact those larger trees, whereas those smaller trees can kind of handle that windstorm. So if you have a blowdown event and you have some of those mid-story, understory trees, they can then occupy that new space. So again, important to have that diversity of ages and sizes. Similarly, there are certain insects that are more lethal to or target certain age classes and sizes. Spruce budworm targets mature trees, whereas white pine weevil targets those smaller white pines. And so, you know, having that diversity is really important to kind of withstand some of those infestations. Similarly, EAB, I believe, targets trees that are over 2 inches in diameter. So we're starting to see a lot more success with biocontrol releases. These are parasitoids that are being released that can pretty much stop emerald ash borer in its tracks if they are in that area. And so by having mature trees that can then produce seed, it can kind of allow for that buffer where we might be able to maintain emerald ash borer. So there's been pretty high success with biocontrols. So emerald ash isn't a lost cause. I know it can seem a little daunting, but there is some hope there. So all this to say that it's really important to have that diversity. We also want to ensure that we have multiple generations of trees because, again, those are your future forest. This is also where you might decide on your own land if you want to plant. You might think about planting something that's in your area but might be in low abundance, but it is expected to increase. And we'll kind of get into that planning a little later. But just highlighting that your tree regeneration, that layer is really, really important for forest resilience. And we also want an appropriate amount of dead wood in both standing and down logs. And so I kind of brought this up, but you know, with the land use history that we've had, we are really lacking dead wood on the ground. We just don't have a ton of it just because of a lot of the practices that have happened over the last 100 to 200 years. And so by adding dead wood into the forest, you can slow, spread, and sink water when we have flood events, especially if you have logs that are perpendicular to the slope. It keeps, you know, erosion from occurring, all of these other benefits, but it's really great for wildlife. And standing dead and dying trees, as well as living trees that have cavities, are going to provide nesting, resting, and feeding opportunities for over 1/4 of our wildlife. So this is a really important component. And if you are a landowner, you love wildlife, this is just a great plug for having some dead trees. And just if you have a big old tree, let it stay big and old and die and, you know, kind of add to this cause. It's really, really important feature. And same with downed wood. Downed woody material is great. It creates these microclimates for amphibians like wood frogs, salamanders. It also is really important drumming sites for our ruffed grouse. Trees that are greater than 8 inches in diameter are going to be those perfect habitats for those species. And then it also provides nesting for some of our native pollinators. A lot of them, I'd say majority, are ground nesters. And so some of that down woody material can kind of contribute to those conditions, but we also have pollinators that will nest inside dead trees. And then if you see this photo here, this is from a harvest. There's a lot of slash left behind, and the reason this is beneficial, not only is it good for the soil, but it can also protect some of the regeneration from being gobbled up by deer and moose. And I'll show a couple more examples of that, but just having that can also be those buffers from larger mammals that might, you know, devour all of your favorite tree species out in your woods. We also want to protect the rare, unique, and at-risk species, as well as unique features or just, you know, natural communities that you might have on your site. And so again, those are really important areas that are worth protecting. They may have special habitat for a certain species, and so
having buffers on those things are really, really important in terms of having a resilient forest. We also want structural complexity. And so what I mean with structural complexity is I mean both vertical and horizontal. So this photo is kind of a good example of that, is you see this really large intact forest, but you also see, hopefully it's not too blurry, kind of these gaps here. So we have some 1 acre gaps, we have some 1/4 acre gaps, we have some forests that were thinned, which kind of mimics a like small blowdown event for a single tree fell over. That's going to allow another tree to kind of occupy that space. And you can see from this image here, you've got some shade on the edge here, but then you have enough space where you have a lot of sun. And this is going to be really beneficial if you are trying to have what are called shade intolerant species. So those are species that love a lot of sun to make it into that canopy. Species like red oak really benefit from that. We're gonna see a lot of that kind of pin cherry and aspen also occupy more of those larger gaps. Our intermediate species are gonna love these edges. And so just having this structural complexity is going to regenerate different species. And different wildlife are gonna occupy those areas. There's just a lot of different things that can benefit from that structural complexity. And wildlife like it messy. A forest that looks like a park, although it looks good to our eyes, it's actually not that beneficial for wildlife. And so this is kind of a good example of what healthy structure looks like. If it doesn't look fun to walk in, it's probably doing a really good job for our species here in Vermont. And so I just want to give some more examples. You know, I'm talking about high structural diversity, we want all these features, but we don't want that everywhere, because if we have that everywhere, then we have kind of the same thing happening everywhere. And so it's also important to have some stands that are also more open, where we have some more young forests. We want more of a mosaic on the landscape. And so again, some wildlife prefer those sparse overstories. Some examples are mourning warblers, brown thrasher, indigo bunting, prairie warbler. I've tried my best this summer to learn my birds, but every year I'm back to the same 5. So if we were out in the woods, I wouldn't be able to tell you which is which, but these species really love open conditions. So again, just highlighting that you want that mosaic on the landscape. And then, to contradict some other things that I've said about the mid-story, some species don't love a mid-story. Species like our little brown bats or northern long-eared bats and broadwing hawks really love kind of those open conditions I showed, and some of those forests that have either an understory and an overstory, but not so much a mid-story. And this allows them to forage more effectively. And so again, if you're trying to promote these species, you might want a different structural diversity than your neighbor. So again, just highlighting that we want a diversity of options here. I know I keep saying diversity. Another example, snowshoe hare love this type of habitat. So do bobcats, because snowshoe hares are in these areas. And then some wildlife really like the dense shrub and ground cover that we have in our hardwoods. So species like the black-throated blue warbler oftentimes are nesting in here. It's a real treat if you're walking in the woods and you find one of their nests. They're so precious and sweet. Chipmunks also use this. You're going to see a lot of these timber tigers running around because it's great to avoid those larger predators. And then, and in between, can you see? Am I blocking? Okay. And in between this is kind of more of that mature forest that we see, where we have our overstory, midstory, and understory, and then pockets of some understory, but also some open pockets. And this is really great for our mature loving species like ovenbirds and veeries, because this is enough habitat for them to be kind of protected in their nest, but not enough that those timber tigers are running around and avoiding our fishers and goshawks. So again, we want to we don't need to achieve everything on a parcel of land, but we want to achieve it on a landscape scale. And so I love this image here of, let's say hypothetically, this is your land and you're abutting this property here that just had some recent large patch cuts, which are going to be great for those species that love open conditions. It's going to be regenerating more of our shade intolerant species. We'll probably get, again, that influx of
pin cherry, aspen, but it'll also probably have more red oak and birch because it's, you know, a larger cut, scarified that soil. But then you also see some of these smaller pockets here. So these might be more like small 1/4 acre gaps that might generate sugar maple. And so as a landowner, you don't have to do those larger cuts because somebody recently did this on the landscape. So you might choose to do single tree selection if you had a rich northern hardwood where beech isn't a concern. Or you might choose to do, you know, smaller gaps or a 1 acre gap. Just understanding the context of your landscape can help you make the decisions that you want to improve your resilience, but also to achieve the wildlife conditions you want. So again, I think as a landowner, it can be really intimidating because you feel like you have to achieve everything on your parcel. And I just want to emphasize that we're all in this together, and so it's good to have that broader lens. Another element of this is that connected forests are more resilient than fragmented forest. And so just plugging that, you know, minimizing fragmentation and permanent land conversion is one of the best ways to create those kind of habitat connectivity that we want to achieve. And that, you know, conservation easements are a really amazing way to kind of protect your land and keep it as a forest in perpetuity. So beyond resilience, we want to think about how we can make our forests more adapted to future climate events. And so adaptation can be defined as intentionally addressing climate change impacts and vulnerabilities to meet goals and objectives for your land. And it's the adjustment of those systems in response. So you're thinking ahead of what might be coming down the pike, you know, and how can we make those small adjustments to be able to kind of withstand those events. And a lot of times these actions are exactly what we are already doing and thinking. It's going to be actions like sustainable management practices, conservation, protecting those rare unique features, and restoration. And then sometimes it might involve, you know, planting some trees in areas where you've had a lot of deer pressure, or you're just not regenerating the species that are going to be suitable for that site in the future. And this, I'm plugging this because I love this concept, but this could be its own talk. So this is called the resistance, resilience, and transition concepts. And so these are actions that are not necessarily discrete actions. They're kind of a robust option. They fall along this like spectrum here. And these are just ways we can think about adaptation in our management. And so resistance, we can kind of think of as putting a bubble over our system. We want our forest to maintain the current condition. We want it to be its historical self, you know, but be able to withstand climate change. And I'll get into kind of how this might look on the landscape. If we choose something that's more similar to resilience, this is kind of treating your forest like a rubber band. So you're allowing for a little bit of change, but ultimately you want that forest stand to stay, you know, maybe sugar maple dominated. And then transition is kind of further along that spectrum of allowing for change in the future. And this is where things get a little bit different. It might involve planting species that are, we would call it assisted migration, which sounds scary, but a lot of times it's planting species that are already on the site. So like red oak, you might not have a ton of it, but it's expected to increase in the future. And so you might decide to do a larger gap and plant a bunch of red oak because it's going to fare better under those particular conditions. And not only could you plant, you know, a specific species, but you could get a more southern genotype that's better adapted to warmer conditions and bring that up a little bit further, just so that by the time it's full grown, those climate conditions are going to match what it was accustomed to. And so I'll give some examples of this in real time. But again, the resistance, resilience, and transition is just one of the frameworks that a lot of times we use, at least in the research world, for applying adaptive forest management practices. So how this looks in real time, this is a project from the Second College Grant. This is owned by Dartmouth up in northern New Hampshire. And I was very fortunate to get to work up in this area. It's gorgeous. And you can see this is a very well-connected, large tract of land. I think it's 2,700 acres. And we've done these treatments. There's 4 replicates of them, but we'll just kind of focus on this one here. So this green one here, this is what is referred to as that resistance treatment. So remember, we're kind of putting a bubble over the system. We want it to stay the same, but we want to add a little bit more resilience into there. And so how that looks in this northern hardwood, which has pretty rich soils for New Hampshire. We're so lucky here. We just have the best soils, and New Hampshire does not. But here's the one pocket where it's kind of like Vermont. They did a lot of single tree selection. So this is just removing a tree here and there. So allowing some of that light and, you know, small gaps into the canopy to encourage new species to start to move into that canopy. And oftentimes this is kind of, that can be reflective of kind of more old growth forest management, which can work in some cases. In some areas you might need to, you know, have a little bit more of a larger gap, and we'll get into that. Then in the orange we have our resilience. Again, you're stretching that forest a little bit further, but you really are kind of maintaining that historical context. And so how this shook out is we did smaller quarter-acre gaps, so smaller gaps throughout that forest to allow for more intermediate shade-tolerant species. So just changing up that species composition a little more, trying to encourage more yellow birch and species like that. And then the transition treatments are where we did those larger gaps, where we have 1 acre gaps and quarter-acre gaps. And so this is encouraging those more shade intolerant species like red oak and other things to come in. We also did do some plantings in here just to kind of add to that mix of adding a little bit more future adapted species, but those that are expected to be in that range. So we're not planting anything crazy, it's things that are already in that area. So this is just kind of how that RRT in action can look. And these are just some options that you can apply. And if you're really into this, I just wanted to plug it because I can't ever not talk about it. If you're feeling wild and crazy, the Adaptive Silviculture for Climate Change, or the ASK network, is a really fun website to go through. It's an international research collaborative across the US, Canada, and Mexico, and there are sites all across, and each one is very tailored to that forest type. So no 2 are going to be the same, but they're applying those resistance, resilience, and transition concepts in real time. And the goal of this is to create this network that landowners can then use to kind of help make management decisions. So, why do we even need to think about any of this? Why do we need to think about resilience and adaptation? Well, as you all know, Vermont and everywhere are facing very complex problems now. We're seeing more extreme weather events, we're seeing increased predation dynamics, we're having a lot more deer pressure, we're having a lot more invasives coming in. We're also seeing more introduced pests like beech bark disease, or beech leaf disease, but also beech bark disease, emerald ash borer, spongy moth outbreaks, you know, things are just kind of increasing. And we're also seeing habitat shifts where the climate is changing a lot faster than natural tree migration can keep up with. And so all of these create really big challenges for our forests that have had a history of past land use that maybe have put them in kind of a more vulnerable state. And so just to kind of touch on pests and pathogens, you know, I did touch on beech leaf disease, and I just want to highlight the concern here is if you did have a very heavy beech component in your forest and you're concerned about beech leaf disease, oftentimes you still want to maintain beech on your landscape. If you have what's called clean beech, where you don't have a lot of those pimples on them, we generally encourage to maintain those. But a lot of managers are making the decision to, again, have a component of beech, but if it's a fully dominated stand, to start to make some actions where you do a larger cut, because beech is very shade tolerant. And so if there is any bit of shade and you have a lot of beech, it is going to be prolific and take over. So doing a larger cut and scarifying that soil, because the leaf litter of beech, I forgot to mention this, takes a long time to break down, and it can inhibit the growth of other species. And so by doing that, you kind of help mix up and reset that forest to allow for other species to start to grow. So again,
I want to emphasize, I love beech. I think a lot of foresters hate beech. It's so good for wildlife, and it's got its own issues, but maintaining on the landscape, but also starting to be forward thinking about how you're going to deal with your stand if you have a ton of it is really important. If you have a lot of deer in your area, you're probably also concerned about your regeneration. Deer really are good at selecting delicious species. You know, you have a red oak out in your woods, that's basically a Snickers for them. And so a lot of times they're going to preferentially eat those good things and leave behind species like beech and the less desirable species. And so some people are experimenting with slash walls. They're very effective. I visited one recently. It was mind-blowing. You step into this slash wall, pin cherry everywhere, sugar maple, yellow birch, everything you can want and imagine. And you step out and it's just a wasteland with some invasives. And so deer really, really can impact your forest. And you know, if you don't do a slash wall, but you have a little bit of concern, you can cage species you want. You can leave, you know, more slash on the ground to protect some of those and create those kind of microclimates where it kind of can prevent them from eating. You could also, in areas with high high deer densities, doing a larger, if you are doing forest management, doing a larger cut is also oftentimes a better option than doing a lot of small gaps, because it will have this big flush of regeneration and it allows for that center to kind of be left untouched while deer generally are going to be on those edges. So just again, the size and how you do it is going to depend on those pressures that you have in your own forest. And then climate change results in greater variability. So as we all know, we have really extreme precipitation events now, followed by extreme drought, and that can be really hard on our species. We're also seeing, you know, 2-degree warming in the summer, but more importantly, we're seeing warming in the winter. And this translates to less snow. And the reason that I'm more concerned about winter temperatures is because snow is so insulative for our roots. And so if we don't have a ton of snow, this experiment was done at Hubbard Brook where they remove snow for the winter. You're going to have deeper freeze-thaw cycles that are going to damage those roots. And then that actually impacts that next year's growth. So you get reduced growth from those trees. You get possibly killing some of those roots. And if that's continuing to happen cyclically, followed by drought and all these other events, we might start to see some more mortality in our forests. So winter warming is pretty concerning. It also benefits pests like hemlock woolly adelgid. These really we need cold lethal temperatures to be able to reduce those populations. And so if we, last year I believe the population declined pretty substantially, but if we continue to have warm winters, we're going to see more episodes of outbreaks. This also allows those pests to kind of start to move further north, and it just can be really unfortunate for our hemlock species. So again, it not only impacts those roots and the growing year, but also impacts the pests that are affecting those species. And then climate regimes are warming at a faster rate than historical migration. So generally trees migrate about 1/10 to 1/3 of a mile per year. Climate is warming 4 to 6 miles per year. And so the reason that this is so important is that this change isn't necessarily going to be reflected in the overstory. We're not expecting trees to just, you know, have mass mortality events. It's again going to be reflected in that regeneration layer. So what's going to come in the future? And these impacts are also more apparent for certain species in certain areas. So many northern and boreal species, so those, you know, ones that require colder temps, are going to be more susceptible to these climate change events. So again, our boreal species are at the southern extent of their range here in Vermont. And so as we have warming, it's going to be a little bit too warm for those species. Similarly, if they are at a marginal site and don't have anywhere to go, it's likely we're not going to have those same species as the climate warms. So again, species that are on that southern edge of the border and at marginal sites are going to be more impacted by this. And this is just a quick summary of the Climate Change Tree Atlas. I love to say, I can't remember who said this, but all models are wrong, some are useful. These are all based on models, just projections of what trees are likely to do better versus likely to decline. And so I just put this here. We don't need to go through it, but if you're interested, the Climate Change Tree Atlas is another very fun website to look through. But a lot of our conifers like red spruce, white spruce, balsam fir are expected to decline, but this doesn't account for microclimates in certain areas. And so again, this isn't doom and gloom. This is just a general projection based on a bunch of different variables. And you know, our oaks are likely to fare better, which you know can be an upside to some of the losses we're seeing. So the last part that I want to just quickly go through is just assessing vulnerability. I want to kind of talk about how we can think about these climate vulnerabilities and then how we can make those decisions. So vulnerability, again, is the degree to which a system is susceptible to or unable to cope with those adverse effects of climate change. And so the way we can kind of break vulnerability down is those, what are the potential impacts that your forest is facing? And what is the adaptive capacity? So potential impacts, we're looking at what is it exposed to? What are those weather events? What are the temperature changes that we're going to see? What are your dominant species? What are the stressors of those species? We want to know how sensitive is that system to your potential impacts. And then on the other lens of this is the adaptive capacity. So how resilient is your forest to the potential impacts? So really we're just looking at, are those impacts going to support or disrupt the health of that forest? And when we talk about the resilience, we're looking at your species tolerances. Do you have drought tolerant species? Do you have species that can handle different freeze thaw cycles? What's your species? Do you have a lot of different species? Do you have landscape connectivity? You know, if we think about a forest in Burlington versus a forest, you know, out here, Centennial Park, not Centennial Park, what is it called? Centennial Woods is not a very well connected forest. It's not going to be very resilient. Whereas, you know, where I live in Northfield, we have a lot of connected forests. And so that's going to allow for a lot of dispersal of seed sources and a little bit more facilitation of movement. And then we want to think about past or current management. Past management can have a huge influence, and I'll give a really good example of this. So we'll pretend we're in the woods. I just want to apply this really quickly. We have a forest here. This is a beech maple birch forest, but we mostly see beech. We have a lot of dominant beech. We have a lot of clean beech. There's not a lot of pimples on these. And when I say pimples, it's just referring to the kind of texture that you see whenever you have beech bark disease. So if we're thinking about our fingers, we do have our overstory trees, but we don't have a ton of our birch and our maple. There's not really a mid-story, and our understory is just a lot of beech. If we look at snags and cavities, we're really lacking those as well as that deadwood component. And that leaf litter is a very thick layer of beech leaves. In terms of potential impacts, you know, we have beech leaf disease coming, knocking on our door. We're also gonna see kind of those more extreme events, and we might have a flood event and there's not a ton of downwood here to kind of slow some of that water. And so I would say that this system is pretty sensitive. And so oftentimes you're gonna have forests that might need some intervention, and then there's gonna be forests that are actually doing really well and might need to just be left untouched. And this is one example that is not the case. So adaptive capacity, we don't really have, I wouldn't say that this forest is particularly resilient. There's just not a lot of that diversity and those kind of layers that we want. And so this is a real world example out at Groton State Forest, where these managers did what's called a low density shelter wood. And this is just a jargony term for, they did a summer cut where they disturbed that soil, they disturbed that leaf litter, but they left a lot of overstory trees, but not so many that the beech was able to kind of proliferate. And so this allowed for future seed sources that then produce seed. And although it's hard to see,
if I were standing in this, you would not really be able to see me. All of these trees are much taller than I am. So we have pin cherry, we've got sugar maple, yellow birch, and we also have some beech still forming here. So we have a really nice mix of future trees in this forest that used to be dominated by beech. And so this is a really good example of one way to add that resilience. So it was kind of a one-age forest. Now it is a two-age forest because we have that overstory. Some of these trees are gonna die and become snags. And then it's hard to see in this photo, but there was a lot of intentionally left dead wood as well. So you're adding a lot of those components that were missing. And it's also lunch for a lot of the species that are in that area. A lot of moose activity, which is great. And then one other example is at Bill Sladek WMA. The reason I want to highlight this project is this used to be owned by a paper company until 1969, and so it was heavily cut over. It was dominated by, I believe it was spruce and fir, and all one age. It was just, everything was the same age, same height, very similar species composition. And so if you think about it from a resilient standpoint, there's not a lot of diversity there, just given that past land use. And so these went in and did a cut recently, and images are just never as good as seeing it in person. But they did these very small, I think the maximum size was 1 to 2 acres, and a lot of them were quarter acres, where they focused on, there's a lot of red spruce regeneration and deadwood, and they left all of that, created these pockets that are gonna allow for that next age class. But then they also left a lot of that interior as is. And so you're again getting those kind of pockets, that mosaic of different forest conditions, which is really important, especially in a setting like this where past land use really rendered this a very unhealthy forest. Here's just another photo of that harvest. It's just such a cool site. And the other really great component of this that often gets left out of the story is the loggers who did this were multi-generation. I believe it was a grandfather through his grandson were on this site. The wood went to the Woods Worm program. It was harvested, or it was milled at a local mill. So it's again contributing to that economy there and staying kind of in that region. And so not only is this benefiting this forest, but it also is beneficial economically for that area.
So is that photo the end result?
This is, yes, and it will look different in 5 to 10 years, but yes, this is from that harvest in the winter. It's hard to see in the photo, but there's a lot of red spruce regeneration there, and a lot of those snags were left. But from a bird's eye view, these would be little tiny pockets among that bigger forest. And so how do we make these decisions? Well, we want to optimize multiple objectives. We don't want to maximize a single objective. And so I really like emphasizing this because I think sometimes it's easy to fall into the mindset of you just want to do something for wildlife, or you just want to generate revenue, or you just want to have carbon storage. And I think a lot of times it's important to think that you can do all of these things, especially at a landscape level. And so these approaches aren't either or, they're kind of a yes and, if you will. And so again, you want to think about that landscape perspective and think about what is missing or what is the vulnerability of your site and how can you contribute to your goals. And again, you can achieve a lot of these things, if not all of them, on the same parcel of land. And so just to kind of summarize, I love plugging this document. It's called Increasing Forest Resiliency. It's written by Dr. Tony D'Amato and Paul Catanzaro. Paul is in Massachusetts. He's an extension professor. But really, it's just we want to keep our forests forested and connected. We want to minimize forest stress. We want to reduce our vulnerabilities of our forest, provide refugia, and most important, especially as stewards of your own land, you want to monitor. You can have the best intentions, you can make management decisions, you can not make, you might choose to do active management, you might choose to do passive management. Both are great options, but it's really important to monitor and see if what you have decided to do is achieving what you think, or are invasives starting to move in, or are you starting to notice more vulnerabilities? And so just emphasizing walking through your forest is really important here. And then the other plug is that not only is this document Increasing Forest Resiliency available, there is one that is coming out in April that is a landowner manual for walking through all of this information I just crammed in here in much greater detail. VT Coverts does a really great weekend intensive on a lot of this material. So if you're interested in doing a deeper dive, I would really highlight checking out VT Vermont Coverts. Restoring Old Growth Characteristics, also a really great document. If you have a really nice rich northern hardwood stand, you're not really concerned about beech, you can use this as a really good guide to kind of add some of those characteristics that are missing if you're, interested in taking that kind of lens. Here are a couple other great resources. We have NIACS, the Northern Institute of Applied Climate Science. They're the foundation a lot of this work. UVM Extension, also a really great resource. And hopefully I'm not too over time. And with that, I'll take questions. And I'm awake, I made it.
So is everybody else, that's even better.
That's true. Thank you.
Very good.
Thanks.
So I have a question. You had mentioned one time maybe planting some oak
Yeah.
from the south or something
Yes.
like that to kind of think ahead.
Yeah.
Is there anything else you can kind of guide?
Oh, I could give another talk on that. So if you are interested in planting oak from a more southern source, I would recommend knowing where your source is coming from. And you don't want to go more than 200 to 300 miles from where you're planting, because once you go past that, you start to see decline in fitness of your trees. So it will just be more maladapted to your site. So that's generally the rule of thumb, is you don't want to go over, I think it might be more than that for oak. I'm happy to share resources, but there are a lot of studies that are used to inform kind of that transfer distance. But that is one way that you can kind of plan ahead on how to deal with a warmer climate in the future. And so UVM is doing a lot of these trials, planting some of those more southern sources. And I think, we don't really, traditionally the Northeast has not been a hotbed for planting, because oftentimes we just have a lot of regeneration. It's just how our forests are. And so this is fairly new. We don't have as much nursery capacity, but I think that's slowly changing with a lot of the issues we're facing. And so there is more availability now. Yeah.
You've been a part of a project or gone to a timber harvest?
Yeah.
Where they did something?
Oh yeah, yes, yeah. I've worked on a couple of the projects. I've done a lot of physiology measurements of the seedlings, and I'm happy to answer questions that you have about it. But we've had pretty good success. So not to get into too much jargon, there are different types of plantings. There's called population migration. So those are planting those species that are found in that native range. They're found on the site, the low abundance, but you're just trying to increase that. And then planting species called range expansion, where they're almost at that site, but they're just a little bit further outside of that area, and you're moving those up. And we've found with the range expansion, so again, not planting anything crazy. These are species that are in the area. Those generally have a decreased fitness, or they just don't do as well, or they take a little bit more to adjust, but it's still, I think we're within the first 5 to 10 years of those plantings, so we'll see as it emerges, but you do see a decline in those species response.
What other species, my last kind of question.
Yeah.
What other species besides that red oak you see in that
do well? We do a lot of red oak, big tooth aspen, red spruce. We've done a lot of red spruce plantings, and the Climate Change Tree Atlas, it does project it to decline, but we're actually seeing kind of a comeback of red spruce. And so I think it's a lot more adapted than we give it credit. I think it just had, I think it was selectively harvested out of a lot of our forests, and so it's starting to come back. There was also the acid deposition that kind of led to a decline that we're kind of getting out of now. So I think red spruce is one that could be a good mix, especially if you're trying to have more of a mixed wood than a hardwood. I'm trying to think what other species we planted. If you're in further south, sycamore is one. I've done a lot of work in Corinth, Vermont, and northern New Hampshire, so it's not quite there, but depending on where you're at, sycamore could be a great option. And black birch is also one that we've planted that's done fairly well. And black cherry. Black cherry is another good one. Sorry. Yeah.
One of our biggest problems with invasives is the Japanese knotweed.
Yes.
And it just overwhelms our watersheds.
Yeah.
Like the White River. And I know the White River Partnership, the local organization, has been planting trees that are conducive to that type of topography and such. But,
Yeah.
is there any way we can, I mean, what is the most, there's probably more than one species that could be planted, not only to counteract the knotweed, but also protect,
Help restore.
the erosion problem that we have when we have
Yeah.
these flood events.
Yeah, that's a good question. I am not as familiar with floodplain species that do well, and I'm starting to have knotweed on my property, so I'm looking for an answer as well. I think a lot of it requires either, chemical treatment, mechanical treatment. It just depends on the amount of energy and effort people have to commit to staying on top of that population before it spreads. The other downside of knotweed that I recently learned is that those roots actually actively erode the soil. It's part of their adaptation, and so it also makes it harder for other species to be able to exist in those areas. And it's such a rapid grower. You can't. Yeah, I don't have an answer, unfortunately.
There's no easy
It's
answer.
yeah. But if you have a small pocket, I've heard that, if you mow it or cut it and just stay on top of it, you can eventually get rid of it. So that's what I'm going to try. So in 5 to 10 years, I'll come back and let you know how it worked out at my property. Yeah.
A friend who is a naturalist and very much into having native species only, she spoke with foresters who, and I think they were in New Hampshire, who suggested, horrible as it sounds, Roundup.
Yes.
But
You
using
drop
a
it.
hypodermic needle
Yeah.
and this is the time of year to do it right
Yes.
now, going, if you don't have too huge a stand, but going right into the stem, and it will travel down through the root.
I will say, I know it can be a hard pill to swallow, but that is the most effective way and the quickest way. And it is such a localized application that it's very safe. It just depends on where you're at and your comfort with it.
Yeah. She hates doing it.
I do too, but
She
it's
hates
also,
the
I hate
knotweed.
knotweed, so yes.
And she said that you get the supplies at Tractor
Yeah.
Supply.
Yes, it's very isolated and very targeted, and it works, but there are other
It's whatever the
options.
chemical name is for Roundup.
Glyphosate, I think, yeah.
This area sends a lot of chips to the Burlington electric plant.
Yeah.
Would you call that whole tree harvest?
Yeah, I would say a lot of times those harvests that go to that area is mostly like you might be doing a harvest that there's not a lot of merchantable timber, and it could be beech or something else, where to make that economically feasible, to be able to add a future regeneration or change that landscape, having those kind of softer markets is really important for landowners to be able to actually afford to do some of those practices. And we actually have the EQIP program, and there's one other program that helps pay landowners to do those kinds of harvests, because again, they're not always economical. You might have very small trees, and it might just be like a weedy forest that you're trying to turn into something that's going to grow red oak and sugar maple. Having those softer markets, I'm forgetting the term right now because my brain's so tired, but I think that those are valuable to have. They're one piece of a very large puzzle. Yeah.
I'd like to follow up on that, because the combustion of wood
Yeah.
contributes to climate change and is detrimental to human health.
Yes.
And so not only with pelletizing it or chopping it, you know, chipping it, but cordwood
Yeah.
is more toxic than even the pelletized versions, and climate people are looking for ways to do carbon capture, sequestration, and storage.
Mm-hmm.
And the best engine for that is our forests.
It's one component of it, but we have to, when you think about electricity also, our electricity comes from Quebec and other sources. I'm not fully equipped on the toxins that come from burning wood, but I heat my home with a wood stove and I love it, and I will never stop because it's just the
I'm not gonna tell people not to
Yes,
use a wood stove.
but I do understand
or to harvest from their own property.
Yes, yeah.
For the cordwood to go into their wood stove. But I will say, you need to know that you are living with significant cardiopulmonary health risks when you're burning wood. It's comparable to secondhand smoke and so that's a reality that people need to know. And I understand that I am in Vermont, and that's a cultural issue as well as a lot of other things. But I want people to know it's not just the carbon that goes to carbon dioxide, but the particulates and the things that impact your lungs. That's a concern I have, and I would encourage the minimizing of.
So that's not my expertise, so I appreciate the comment, but I focus more on tree physiology and forest management, so I'm not well versed to be able to speak to that.
I want resilient forests.
Yes, I think we all do.
I want to harvest for,
but having that balance. No, I appreciate that comment very much.
So there needs to be a balance.
Yes.
But even with the balance, I think we should minimize combustion.
No, I appreciate the comment. Yes.
I have a very local question, my backyard.
Yeah.
I was always taught that you stacked brush in brush piles. And watching tonight, I was interested in the slash wall.
Yeah.
And it got me thinking that maybe I should be more thinking about when I'm cutting brush to kind of spread them like pickup sticks.
Okay, yeah. Rather than piles. You know, I think either option is great. I think you'll attract different things depending on the height and the spread of your brush. But within I guess more of what I'm getting at other than in backyards is that within a forest, you don't necessarily need a manicured forest for wildlife. That was more of what I was getting at. But I think if you are doing brush piles, wildlife, they're going to use it, they're going to love it. And a lot of times you'll also find bumblebees kind of in those areas where they're kind of protected. So leaving it and not disturbing it also is an important aspect. So it's great that you're doing that.
Although in the day of drought and fire risk,
yes,
you got to be careful.
You do have to be careful. It's very true.
How big they are and all that, and what
yes.
they're next to.
Yeah. No, definitely.
Soon we'll have to worry about it.
I know. Add it to the list.
It's a whole new layer, right? And
yeah.
pigs and all kinds of things. See?
Yeah.
They would be a huge change.
Yeah. Oh my gosh. I think we are expecting it to be drier and also wetter. So we're expecting more, I know, so more extreme events. So we're expecting really extreme rainfall events punctuated by long periods of drought followed by periods of high precipitation. So those are kind of what we experienced this year, especially.
Kind of
Unfortunately.
antagonistic.
Yes, yeah.
With climate change projected to increase, what is your concern about several forests or the state having something like a Palisades-like fire with the fire nados?
Yeah, with the fire nados. Yes, that is. So I lived in New Mexico for a while, so it was a much bigger concern there, and I think it could be a concern here, but we still are such a wet forest, like it's the asbestos forest. I don't think it's as much of a concern of having extreme fires. I think it's more of just persistent, slow burning, long fires that aren't necessarily detrimental, but are still kind of a risk in their own. I don't think, but don't quote me because I don't know, but I don't expect fire nados happening here.
But we don't have
hopefully.
a lot of those kinds of fuels. We
No.
don't have those explosive soft
Yes.
vast amounts of those.
Exactly.
But there are now, we do have suburbs. People have been making expensive developments in
Yes.
the midst of trees because they like that setting. And,
Yeah.
That's happening all over, and
Yes.
is potentially even in these smaller scale fires
Oh, no, absolutely.
a potential problem.
Yeah.
And there's a lot of, those soils when they're dry actually burn, and the water, the fire will actually go underground and burn
burn through.
persistently and travel.
Yeah, yes.
Yeah,
So
there was the one in Killington was that 2 years ago?
I think it was 2 years ago, and they
And
took
it
heat
was a
images.
monster.
Yes.
Could be
it-
very sneaky.
It's very sneaky, and the images they took, I can't remember what the kind of drone it was, but it showed, you could see the pockets of it. So we have a fire team who could be a great future guest to give a talk. But they do, we're thinking about these things, and
Yeah.
I mean,
It's a lot.
it's a lot, yeah. Yeah.
On the topic of fire, is there any role for prescribed burning in management to do?
Oh yeah, we do prescribed fires fairly often. I would say the Green Mountain Forest does more of it just because they have larger capacity. But prescribed fire is a great way to regenerate certain species, especially, I know I keep talking about red oak because it's my favorite species, but it's a great way to encourage those species. And Bartlett Experimental Forest, actually, I toured there recently. They had, I think it was 20 years ago, they did a prescribed fire versus an unmanaged area. And just the species composition is just different because it encourages different species. So yes, it can be a really great tool, but it's also one of those tools that has to be done very safely with very specific conditions. And it's harder in those areas where you might have somewhere that needs a prescribed fire. If a lot of our pitch pine forests need fire, but they're within developments, and so it's hard to achieve those conditions whenever you're within, settlement areas. Yeah.
We had several days in Randolph when it was on next to one street. It seemed like it was raining acorns from red oak.
Yes.
What's
It's
that
a
all
masting
about?
year. So I can't remember I think it's like every 2 to 3 years you'll have a major mast event with oaks and other species. So this year just happens to be a really good mast year. And so it's kind of a strategy of they put all their effort and they dump all of these acorns, and they're kind of just oversaturating so that, the squirrels are going to forget where all of those stashes are. And so that kind of ensures future regeneration of those acorns. And I really love during mast years collecting them myself, and then you can scatter them in your own woods and see what comes up. It's an easy way to kind of do, these adaptive plantings with no budget.
I've been doing that.
Yeah, yes.
But what do you recommend, or how should I plant them? I was
They-
just throwing them, but I don't think.
So they actually, I can't remember the cost of it, but Forestry Supplier sells an acorn planter. It's like a little tube that you just like pop in the ground and drop it in. And you just can walk around and,
Yeah.
yeah.
Just make a hole.
I just make a hole.
Do you think
See what
you
comes
would,
up.
Squirrels do.
Exactly.
Same thing.
But the deer, we do have deer
Yeah, they
that
like
come
Yeah.
through our property. So That's the only issue I was wondering, because they just won't get past that stage unless you have enough of them.
Yeah, it depends on if you have a lot of deer versus, a couple. They might be fine.
It's a
And
resident herd sort of thing.
yeah.
I think they'd have to be caged until they were high.
You could also, they found success, slash holes are a huge investment. It's a ton of material. But you could also, I think it's a 16 by 16. They found that if you fence a small enough area, it's small enough that they're not going to want to jump in because, so you could, if you really wanted to plant, you could do a really small fence around it. And you'd probably grow something. You'd probably grow a lot. Yeah.
Where in the spectrum for resilience to black walnut and butternut?
Ooh, that's a good question. That would probably be more of a transition planting, depending on the area you're at. But I do know some people are planting black walnut on their property. I would say that's more of an assisted migration species.
Kind of find the black walnut. We have one black walnut.
Yeah.
It just sprouts up trees like crazy.
Yeah.
There's seedlings everywhere.
And is it true that it kills other trees that are around it?
I think it does have some allelopathic behavior. Yeah.
But whatever, if you're going to plant something, you should probably plant something that matures really quickly.
Yeah.
Because you need to change and plant something else.
Yes, please, please. I don't have experience with black walnut, so.
Years ago, we planted a black walnut.
Yes. So you are the expert. I am excited for this.
I am trying to find someone who will come and use the forest that's growing in my yard. Because every time you cut off
it
a
re-sprouts.
small tree, it sprouts up 6 or 7 sprouts.
Yes.
So I'm at the point where I need to remove those black walnuts.
Okay.
Or I won't have any yard.
Yeah. So this is a great example of an adaptive trait that species has. Some are really good at sprouting, and so that is a very resilient tree, but it's not the tree you want.
And if you want squirrels,
you've got them.
one tree.
That's okay. Well, I think we have our answer on whether or not we should plant black walnut.
It likes it here.
It likes it.
Okay.
I also have a question.
Yeah.
We as a conservation commission are considering or going to do the cutting in the Quimby forest.
Okay.
And I
Is it a town forest?
Yes.
Okay. Okay.
And I would like to, I feel that we need to assure that we meet all of these standards that we've been talking about. Now, what's the best way for us to ensure that happens? I mean, we have a plan created by a forester.
Okay. Who's your town? I'm guessing you have a county forester who worked with you. Who is it?
It used to be AJ Follansby,
Okay.
and now Dan Healy.
Okay.
It's AJ's forestry plan.
Gotcha. Okay. Well, I would say the best way to ensure that those objectives you have all laid out. Have you already done the management?
Yes, the management.
Okay. That monitor your forest, and just, I would say every couple years assess and make sure that the goals that you set out through those activities you all did. I don't know exactly what the harvest looks like. Oh, you haven't done anything yet. Okay.
We want to assure that it
Yes. Well, the problem is we can't assure anything because it's nature and it's wild and you never, but I would trust AJ. He's a very good forester, and I'm sure he's looked at these vulnerabilities, and I would say once you do this harvest, I would monitor the first year, the third year, the fifth year, and just make sure that you are regenerating those species you wanted, and that you're seeing the wildlife you want, and that invasives aren't moving in. So I think that's the key piece, is you can have these great goals and you can do that, but something might happen. You might have some kind of crazy event or deer come in, and so then by monitoring, you then allow yourself to be able to intervene and help kind of turn it around and keep it on track. And so that's the most important piece.
But we can feel reassured that the plan is probably what it
I would guess so. AJ is a very, very great forester, a very thoughtful forester.
Okay.
Yeah.
That's good to know.
Yeah, we've always thought so.
Yeah.
So.
Yeah, thanks so much. Okay. Any other questions? And if not, you know where to find me.
It might be too late.
It might be too late.
And do you need to plan for invasive control after harvest?
I would say, I mean, if you don't have invasives, no, but if you start to see invasives, then I would. And also, that's another important piece of monitoring is you might not have noticed some honeysuckle, but if you're on a walk and you start to see it, I would, pull it out, keep the roots up off the ground. It's just a great way to just stay in touch with what's going on. But forests that are closer to highways, that are closer to more activity are likely going to have more influx of those invasive species. So just, again, monitoring is the best way. Yeah. Any other questions?
So now I think we need to let you.
Oh, okay.
Have some sleep.
I know.
And then you can use
Okay,
it.
thank you so much. Thank you.